Assalamu alaikum everyone. Welcome to another video of Chemistry with Sarab Tasambeg. In this video, we're going to take forwards the dot and cross diagrams. So let's look at another dot and cross diagram of a molecule called CH3OH. When I look at CH3OH, this is an alcohol which we will study in organic chemistry, and the name of this alcohol is methanol. In this is kind of a complicated molecule, but it's easy to decipher how we are going to make the dot and cross diagram for this. It's carbon bonding with 3 hydrogens. So first I'm going to make a carbon atom. And obviously carbon has 4 electrons in its outer shell. So I'm going to bond this carbon with 3 hydrogens first. So 1 hydrogen, 2 hydrogens, and 3 hydrogens. But carbon still has 1 electron which it hasn't bonded anything with. So that carbon will bond with that 1 electron with oxygen here. So carbon is satisfied. It had 4 electrons, it got 4 electrons. Now the issue here is that oxygen has 6 electrons in its outer shell. So oxygen 1, 2, 3, 4, 5, 6. Now the 6th electron of oxygen will be bonding with a hydrogen atom. So it will look something like this. Keep in mind that there are 3 elements in this molecule. And in dot and cross diagrams, you can only use dots and crosses. So I have used the dots for carbon and the crosses for hydrogen. And then for the next diagram, since carbon was crosses, then oxygen was dots, and then if oxygen was dots, then hydrogen was crosses. So alternating dots and crosses. So this is how all the atoms are having full outer shells and are getting the electronic configuration of noble gases. This is a methanol molecule. Let's take another example of ethene gas, C2H4. C2H4 is ethene gas. This is a little bit complicated. Why? Because there are 2 carbons and 4 hydrogens. So how am I going to look at this? 4 hydrogen means that carbon can have 4 hydrogens. Like in methane gas, CH4, each carbon was covalently bonded with 4 hydrogen atoms. But in this case, you have 2 carbons. That means these 2 carbons are bonded with each other. These 2 carbons are bonded with each other. So carbon, carbon. And I can easily say that if it's 2 carbons bonded with each other, then 4 hydrogen means that each carbon atom is bonded to 4 hydrogen atoms. So 1, 2, 3, and 4. Each carbon is covalently bonded to 2 other hydrogen atoms. However, carbon has 4 electrons in its outer shell. So 2 have already been used, and 2 electrons are coming from this carbon, and 2 electrons are coming from this carbon. Hence 4 electrons are being shared here in this case. And this is different now because in all the above cases, we were only sharing 2 electrons between 2 atoms. Here 4 electrons are being shared between 2 atoms. So this is a double covalent bond. This is not a single covalent bond. This is a double covalent bond. Now we'll write a note over here that it's a single covalent bond. It's a single covalent bond if 2 electrons are shared. It's a double covalent bond. It's a double covalent bond if 4 electrons are shared. And interestingly, there is also a triple covalent bond, which we will see in the next few minutes. Triple covalent bond when 6 electrons are shared. 6 electrons are shared. Let's look at another example of oxygen gas. O2. Again, it's just O2, so this is also oxygen gas and it's a diatomic molecule because it's just comprising of two atoms. It's diatomic. With oxygen gas, oxygen has 6 outer electrons. So and it's just two oxygen atoms bonded together. So oxygen and oxygen. So 6 electrons in its outer shell. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. But it has to share electrons. So how would they share then? So 2 electrons will come from this oxygen. 2 electrons will come from this oxygen. And 2 electrons will come from this oxygen. So I'm going to remove these 2 electrons and put here. Now each oxygen has 8 electrons in its outer shell and are getting an electronic configuration of a noble gas. Again, there is sharing of 4 electrons, so this is going to be a double covalent bond. Let's look at another example of carbon dioxide. When we look at carbon dioxide, CO2, this means that carbon will be the central atom because carbon shares 4 electrons. So carbon is the central atom, and alongside carbon there are 2 oxygen atoms, one here and one over here. One here and one over here. 2 oxygen atoms. Now carbon shares 4 electrons, so 2 here and 2 here, because it has 4 outer electrons. Each oxygen atom shares 2 electrons, so 2 here, 2 here. And then oxygen atom has a total of 6 electrons of its own and 2 it gets from carbon. So 6 electrons means it has 4 more electrons here, and this also has 4 more electrons here. Now again, each atom is having an electronic configuration of a noble gas, which is 8 electrons in its outer shell. However, it has 2 double covalent bonds. So carbon dioxide has 2 double covalent bonds. One double covalent bond is with one oxygen, one double covalent bond is with the other oxygen. Carbon shares 4, so basically the crosses are carbon's electron and the dots are oxygen's electrons. Let's look at one last example, and that is of nitrogen gas. Again, by looking at the molecule, it's a diatomic gas because it just comprises of 2 atoms. And nitrogen is different because nitrogen shares 3 of its electrons, because nitrogen is 2, 5. So nitrogen needs 3 electrons. If nitrogen needs 3 electrons, then each nitrogen has to share 3 electrons. Basically, the rule is as much electrons as you need to share those electrons. So nitrogen needs 3 electrons. So 3 electrons from this nitrogen and 3 electrons from the other nitrogen. Now it itself has 5 electrons in its outer shell, so 2 here, 2 here. This is the nitrogen dot and cross. Now this nitrogen dot and cross is different and weird because nitrogen has 3 or a triple covalent bond, sharing of 6 electrons, triple covalent bond. Again, nitrogen needs 3 electrons, so each nitrogen will share 3 electrons, which means sharing of 6 electrons. When 6 electrons are shared, then if nitrogen is sharing 3, out of 5, 2 will remain in the outer shell, like that. They're not taking place in any sort of sharing, but they're there in the outer shell. So this is it about today's video of all the dot and cross diagrams we have made. In the next video, we're going to discuss about the properties of these covalent molecules. Till then, thank you very much, everyone.